Hi chemists, this video is all about the dissolution reactions, as the title says. So I'm going to talk through the concentrations of these dissolution reactions and the concentration of ions in particular. Okay, let's get started. So let's talk about writing equations for these. So we write equations for dissolution reactions, even though it can be argued whether they're a reaction or not. Is it a physical or a chemical change? Open to so much argument. Let's not bother with it though. But we do for dissolution, we do write equations for them. Okay, so for molecular dissolution, when you've got a molecule just dissolving, it's not dissociating is the word, or ionizing. All we do is change the state on it. So here I've got, is it sucrose? One of the sugars anyway. It hasn't changed its formula. It's still the same molecule, but what we've changed is we've taken it from a solid and now we've dissolved it in water. So the change of state from the solid to the aqueous tells us the story that we've dissolved it in water. So ionic compounds, remember, they dissociate in aqueous solution if they're soluble. Okay. If they are soluble, we can write an equation for it that separates the ions. And this is best for the beginner. There's another way to do it that is quite often used for chemists, but we kind of know what's going on anyway. Anyway, words. So, okay. So what you should do, say if we had a barium chloride solid and we're dissolving it in water, how we'd write that was we'd do the reaction arrow and we'd separate the ions as we've got one ion of barium, which is 2+, and we've got two chloride atoms there, two chloride ions there. Okay, aqueous state, separated is showing that they dissociated. They didn't ionize because they were already ions, but they've dissociated, they're separated. Chemists often write this and can do it in a shorthand way. We will sometimes write it as barium chloride solid going to barium chloride aqueous, the same as if we do molecular dissolution. But a chemist will have enough skill to look at that barium chloride and the aqueous state and know that barium chloride is soluble and go, oh, well, I know that they're dissociated. Okay, so I would like you to do the first one and not be lazy and do the second one. It really says to you that they're dissociated. But if you come across the second one, don't be fooled, okay? So do this. Separate out those ions. It will help you with some stoichiometry problems, like I'll show you in the examples coming up in the next slide. I think it's the next one. Okay, for ionizing compounds, for moleculars that ionize, we give the ions as separate products. So here I've got phosphoric acid. It's a molecule and it ionizes in water. So 3 of the hydrogen plus ions come away, aqueous, and 1 of the phosphate ions comes away, aqueous. So that's how we write ionizing products. Okay, even though, so we're starting from a molecule and we're going to 2 ions or more, usually 2. Okay, let's do a problem. Determine the concentration of sodium ions and carbonate ions in a 0.1 mole per liter solution of sodium carbonate. Okay, what we're going to start first is a sodium carbonate dissolution reaction. Na2CO3. And let's pretend we're dissolving it. We're going to get 2 sodium ions, aqueous, and the 1 carbonate ion. Okay, it gives us the stoichiometry of for every 1 carbonate, for every 1 sodium carbonate, I'm getting 2 sodium ions and 1 carbonate ion in solution. Okay, so the concentration for the sodium carbonate is given in the question there as 0.1 moles per litre. Let me just write that in there, 0.10 moles per litre. So it's asking us to determine the concentration of that guy and that guy. And we can use the stoichiometry. So the concentration of sodium plus is going to equal the concentration of what we know times it by the molar ratio, okay? And so we need the molar ratio between sodium carbonate, and we're trying to find out the molar ratio, the concentration of sodium plus, okay? What's out the front of those two? Well, there's a 2 and a 1. So the concentration of sodium ions is going to equal 0.10 moles per litre times it by 2, which equals 0.20 moles per litre. Okay, let's do the same as for the carbonate. The concentration of carbonate, remember that square brackets equals concentration in chemistry. Our concentration of our known times it by the molar ratio. This time we want the molar ratio between carbonate and sodium carbonate. What's in front of each of them? The stoichiometry. I'll change it to purple to keep it consistent. 1 and 1. So for every 1 sodium carbonate, I'm getting 1 carbonate. So the concentration equals 0.10 mole per litre times it by that 1, which equals 0.10 moles per litre. There we go, answered the question. We determined the two concentrations of the sodium ions and the carbonate ions. Let's do another problem. Okay, calculate the mass of calcium hydroxide. Ooh. Needed to make a 100 ml solution with a hydroxide concentration of 0.50 moles per litre. Okay, so it's asking for a concentration of a certain ion. Alright, let's start with our calcium hydroxide. What's the formula for it? We need 2 hydroxides for every 1 calcium. Calcium is 2 plus because it's in group 2. Hydroxide is 1 minus charge. So we need 2 hydroxides for 1 calcium. And it's going to dissolve to form 1 calcium ion. And the 2 hydroxides are going to be floating around separated in solution. Okay, let's have a look. The question says we want a hydroxide concentration of 0.50 moles per litre. And we want to make a 100 ml solution of it. Okay, so we want 0.1110, 2 more zeros, litres. Okay, so we can work out how many moles of hydroxide we want or need. Equals the 0.5 times 0. So that's 0. I've gone to my eraser. 0.05. Let's add a few zeros in. Moles. Okay, so if I need that number of moles of the hydroxide, how many moles of calcium hydroxide do I want to give me that concentration of hydroxide? So our moles of calcium hydroxide needed is going to equal the moles of hydroxide. Oh, I haven't put the number first, have I? Equals the 0.05000 mole of hydroxide times it by a molar ratio between the two. What do I want on top? The calcium hydroxide. And I want to get rid of the hydroxide on the bottom. Okay, what's in front of the hydroxide? A 2. What's in front of the calcium hydroxide? A 1. Okay, so times it by a half. So we need half the amount of moles of calcium hydroxide. Yes, I'm putting it in my calculator. I'm brain dead. That's okay. In your exam, you'll be brain dead too. As I thought, it was 0.025 moles needed. It's asking for a mass, though. A mass of calcium hydroxide. Okay. So I'm going to need that number of moles times it by the molar mass of calcium hydroxide. Periodic table. Luckily I have one handy. So it's 40.08 for calcium. Plus we need 2 oxygens, 16.00, plus we need 2 hydrogens, 1.008 grams per mole. Okay, don't forget those brackets to get order of operations, otherwise you'll get a ridiculous answer. Times bracket 40.08 plus the 2 times 16 plus the 2 times the 1.008 for hydrogen gives me 1.8524 grams. Okay, significant figures. The concentration was 2 significant figures. The volume was 4. Our molar masses were 4, so we're limited to 2. The 1, 8, the 5 is the third, so that 8's going to jump up, so it's going to be 1.9. Oh, I put a little tail on that one. 1.9 grams to 2 sig figs. All right. Couple of examples there. Next up, I'm going to talk about reactions in solutions, and then we'll do a few more problems. Thanks for your time.